Hi, how you doing? Isn't this a cool conference? I'm so happy to be here. It's my first trip to Thailand. Are you all having fun? Cool. How about a big thank you for our organizers? This is such a great event. Best conference food I've ever had also. The meal yesterday was amazing. I'm really looking forward to lunch. So my name is Brad Urani. I work for Procore. If you need to contact me, you can get me on Twitter. I will not call it X. It's Twitter. It'll always be Twitter to me. I don't use it anymore, but that's my Twitter handle if you want to find me. I work for Procore. Procore makes software for the construction industry. The world's largest construction projects will run on Procore. If you need to build a skyscraper or a subway or a stadium, you use our software. Here's an example of someone out in the field using one of our Procore drawing apps to build something important. We are a Ruby on Rails success story. We IPO'd in 2021. That is after 18 years of developing our solution on Ruby on Rails. We started our Ruby on Rails app on version 0.9. I think it was like 18 or 19 years ago. Of course, we're not just Ruby on Rails, right? We're doing a lot of very interesting things. We have machine learning these days. We're doing augmented reality for construction sites where you can walk around a building that's under construction and have detect defects, take photos with a helmet on a camera. We're doing a lot of AI. We have integration with drones that fly around buildings and take photos of them and really neat stuff like that. I am the principal architect on our streaming platform. Streaming is what we use to basically connect services. Connect services and applications together. It's like the central nervous system for our solution. So we have a lot of services. We have applications. They all need to talk to each other. We run Procore in multiple regions, in Europe, in USA, and in Canada, and other places. And those different regions need to communicate with each other to share data. And so I work on that. It's global type system. It's distributed systems, right? Streaming data. True story about Procore. We have, I think, the world's largest Ruby on Rails app. Maybe, depending on how you count, right? Actually, these stats are from a year ago, but we had 43,000 files, 1,123 tables. I think Shopify, we might be like tied. I talked to a Shopify engineer at the last conference, and depending on how you count, I think they had more lines of code, but we had more models. I think we have 4,000 API endpoints, which is more than they had in one app. And I think we have like 300 people working on it between the front end and the back end, one app. But of course, like I said, we don't just do Ruby on Rails. We have all these other downstream things, artificial intelligence, right? We have a whole platform just related to search. We're rebuilding that now to use ChatGPT for natural language search and things. We have this reporting. This is enterprise software, so we have like a whole reporting platform, when you need to spit out big spreadsheets full of numbers and export PDFs and things like that. And that brings up some very interesting technical challenges. In working on the system, we have to answer some of these questions. Like, first of all, we have this huge Rails app. Like, we kind of want to split this up, and move to this kind of service-oriented architecture, microservice world. Like, kind of how do we do that? That's hard. How do we handle this, like, multi-region support when we have a data center in Europe and a data center in North America, right? How do we, like, kind of share data? Or if one region needs to access data in another, how do we do that? A common thing in large Rails apps, right, is we originally built our search feature into Rails, right, using like Postgres search, which, that's fine when you're a startup, but, we need to move beyond that and move our search out. Same with reporting, right? And how do we sort of communicate with all these new services? And in the process of all this, what we need is end-to-end consistency. So I'm going to define consistency because you're going to hear me say that a lot. That's like the word of the day, consistency, okay? Consistency means when you have multiple services and multiple data stores, that if you need to replicate data from one app or data store to another, that they are 100% the same. That any change to one database, right, the state in one database appears in the other. Right? So if we have a new service, right, and we've got our original Rails app, we've got a new service, and it needs user records, we have to make sure that all the users are in both these services, in both these databases, right? Or if we're breaking out our search into Elasticsearch, right, and we have our primary Rails database in Postgres. Why are some of my icons not rendering? Oh, weird. Huh. There's a big elephant on my screen. Anyway, we can't have like a record go into our primary Rails database and then not have that record appear in Elasticsearch, right? Or people will get the wrong search results. For reporting, we use Snowflake, which is this great BI reporting database. If it's in the main database, it has to be in Snowflake too, or people's reports will be wrong, right? They'll be inconsistent, and that's bad. So we need a 100% end-to-end consistent solution here. Okay, so quick question. What is the best way to make two Rails apps talk to each other? Or these can be Sinatra services, right? Microservices, whatever you want. What is the best way to make two services talk to each other? It sounds like a simple question. It's really not. So one thing we could do is just have one post to another. Simple, but this actually has a lot of problems, right? What if the server, whoa, I don't have my, what's that? Oh, weird, it's just delayed. Huh, I'll just talk slower. Yeah, it's eventually consistent. All right. Okay. Okay, just posting from one app to another, right? This doesn't work really well because what if the downstream one is like offline? What if you're deploying it or if it's overloaded, right? Or you've got a network error and you can't reach it, right? In the upstream one, you can retry, you can sit there in a loop and make the user wait, and you can retry and retry, but eventually you have to give up. Eventually you're gonna fail. And you either introduce inconsistency or you return an error back to a user. This isn't really durable. This isn't really, it's just not high availability. It's just bad practice, right? gRPC here, it is faster, it's more efficient, but it's basically the same thing with the same problems. It doesn't really help you. What you need is something between these two services, right? And it goes by many names. You might call it an event bus, right? There's a picture of a bus, get it, event bus, and it's a bus. Yeah, a transaction log, you might call it. You might call it a stream, a pub sub, right? It goes by many names. For you people born in the 90s, right, that black and white thing, that's a newspaper. It's like the internet, but like on paper, kind of before the internet. Usually this is Apache Kafka. Kafka is this open source, free event bus system that's just absolutely wonderful. It's how you get a message from one place to another. There are some competitors. Kafka's not the only choice. Amazon, AWS, right, has this technology called Kinesis, which is very similar, not as full-featured. Google Cloud has PubSub. I've never used it, but I've heard it's pretty good. Most of the time, people are going to use Apache Kafka, and it's what I recommend. It has the most tooling, the most features. In Kafka parlance, right, we have a producer. That is something that publishes a message to Kafka. And we have a consumer. That's something that subscribes to and reads the message, right? And when you produce, you go into what's called a topic. A topic is it's like one queue, right? So you may have like a user topic, right? Where all your user records go in there. So you produce to a topic and then you consume from a topic. Why Kafka? This is Franz Kafka, the writer, after it's named after. He wrote this great book about a man who turns into a cockroach. If you read it, it's fantastic. Kafka gives us a few really, really interesting properties that make this a really outstanding solution. The first one is at least once delivery. What this says is if you have your producer and your consumer set up correctly, the consumer will always get the message. Always. It will never skip or drop a message. You are guaranteed to get it at least once. It does this using durable disk storage, right? I could go into Kafka internals and how it works, but I don't have time for all of that, but you always get the message. It has guaranteed ordering. What this says is that when you write messages to Kafka, the order in which you write is always the same order in which you read, and that is a very, very important property, and that's not true of many other queuing solutions. You have multicast. When you publish something to Kafka, you can have many different subscribers, and you can always add new subscribers, right? It's not just one producer, one consumer. You can keep adding on more and more and more. You have other teams. They may have new solutions. They may find that, hey, you have this data in Kafka. I want to read that too. I want to populate my AI solution or my augmented reality solution over here or save it to my new search index. It's really great. It is replayable. Unlike other types of queuing situations, right, queuing solutions, when you put a message in Kafka, it remains there even after you've read it. There's a certain retention window. It's configurable. Ours is set to 1 week. So those messages stay in our Kafka cluster for a week. And that's great because, like, say you mess something up, like you're inserting into a database and you forget to add a column or something. You can go back and reread all the messages and fix that, which is really wonderful. And so, with at least once delivery and guaranteed ordering, we have a consistent system. You can trust that your upstream producer and your downstream consumer will always be eventually consistent, right? The message will always get there, it will always be read, and as long as you handle it correctly, you're not going to lose anything. With multicast, it is democratized, meaning you can put the data out there for your organization and any other team can go and read it if they want it. It is decoupled, right? It allows us to separate services. And because it is durable, it uses disk-based storage, it is high availability. It's wonderfully reliable. I've never had a problem with it. In 7 years, we've never had a real outage with Kafka. So the answer to the question, right, how do you make one service to communicate with another? Use Kafka. With this, you get buffered solution. That means if you get a flood of messages in your upstream app, right, maybe the downstream one is slower, maybe it takes longer to insert. Kafka will buffer that, and the downstream one can consume it at the rate it can, right? You don't lose those messages. It's durable. Whoops, I spelled that wrong. It's consistent, right? It's replayable, and it's democratized. Now, I did want to mention these other queues because you all use like Sidekick for Redis, right? I don't know if you've realized that, but that is not ordered. If I enqueue 6 Sidekick jobs, there is no guarantee in which order they are read in, and that can cause people problems. RabbitMQ and SQS, there are different ways to set those up, but they don't all have these properties. They're not all ordered, and they don't all have retention, right? Usually when you dequeue these messages, they're gone, and you can't replay them. So choose carefully what you use for your queuing technology. And when you want to get on Kafka, right, you've got a number of choices. For instance, we use Amazon hosted MSK, right? You don't have to run your own Kafka brokers. Heroku's got a great one. And actually, we're switching to this one, Confluent Cloud. Confluent's like the Kafka company. It's run by the founder, the guy who invented Kafka, Jay Krebs, right? He founded this company, and now they do tools and support and stuff. And their solution's the best. They have a lot of things added on, like above and beyond Kafka, that are really useful. And for you Rubyists, right, there's this wonderful gem called Karafka. It is a wrapper for the sort of Apache C++ kind of canonical library called librdkafka, and it's fully featured. It's got everything. Big shout out to my pal Maciej Mansfield. He lives in Poland, and he maintains this gem, and he just does an awesome job. So let's talk about how to use Kafka right. If we want a consistent pipeline, the first thing we need to do is consistent production. And while it's pretty simple to write messages to Kafka, there are a few gotchas and things you need to be aware about. So, there are kind of 2 modes for producing to Kafka. There's synchronous and asynchronous. Synchronous is the simplest, right? So imagine I've got this Rails app, a post comes in, I enqueue something in Kafka, I get back the ACK, right? All right, it's in the queue, good. Return success 200 to the user, great. So that's the simplest method. Realize that if for some reason you fail to Kafka, you just have to set up your error handling right so that you return an error if it doesn't make it to Kafka. Kafka is high availability. It very, 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 very rarely happens. But you just want to make sure you return an error if you don't get it to Kafka or you get inconsistencies. You can also do asynchronous producing in this mode. When you write a message to Kafka, it actually queues it in a background thread, which goes and publishes to Kafka like a little bit later. With that, you get better batching of messages to Kafka, higher compression, and you get a quicker response back to the user because you can write to this background thread, right, and return a response immediately, and then later it actually gets enqueued to Kafka, but be careful, right, because that is not consistent, because if it fails, you've already returned a success message to the user, but you've not actually gotten it to Kafka. So once again, these problems are rare, but they do happen. It is not consistent. There's a little bit of a catch to all of this, right? I showed you this. For the synchronous production, I left something out of the first diagram, and it's the database. You run into some problems right here if you really need absolute 100% consistency, because that means if you have a Rails app and you get an inbound request and you write to the database and you write to Kafka, you have to make sure that those both succeed or both fail, or those 2 data sources are not going to match. So imagine for a second, right, your inbound request comes into your Rails app and you publish to Kafka. Then you open your database transaction, insert a record, commit, done. Good, right? Not quite. What if this transaction rolls back and fails? Then you've got something in Kafka, but not in your database. Oh, I know, let's put it at the end, right? Now we know that the database transaction has succeeded. Now we publish to Kafka. We're good, right? Not quite. What if it fails to publish to Kafka? Then you've got it in your database, but not Kafka. Oh, let's just put the publish right in the middle of our transaction. All right, now we get it in the database, right? We publish to Kafka. No, it can still roll back, can't it? Yeah, so now we're inconsistent again. This is the dreaded dual write problem, right? It's a common problem anywhere. A little side note, right, off of Kafka for a second. Do you all use like Sidekick? Do you ever like insert a record into a database and then enqueue a Sidekick job? If so, you have the same problem because you're not guaranteed to get it in both places. And that's a common source of inconsistency in a lot of people who are using these type of systems, right, with like Sidekicks and things. You got to realize it might not end up in Sidekick if it ends in your database or vice versa. That's a dual write again. Those things, they sneak up in weird places, and some people don't know about that. There is a solution, but it's complicated. I don't necessarily recommend it unless you really want a lot of ops overhead and you've got a really good team who really knows their DevOps and their database stuff. It's called change data capture. Once again, ask yourself if you really need this because it's complicated. You might be able to live with some inconsistency, right? I know a lot of organizations, they do a dual write to Kafka in a database, and then they have like some batch process that runs like maybe at night or every hour to like check for inconsistencies. That's a pain in the butt, right? But it might be simple than change data capture. How do you actually do this, right? If you're using like DynamoDB, for instance, or some other databases, your cloud provider might have a solution, right? They've got this integration called Kinesis Data Streams that automatically does change data capture. So every row that gets written automatically gets added to this Kinesis stream, and then you can get that into Kafka through various means. If you're like us, right, and you're using the world's greatest database, PostgreSQL, you need to use this technology called Debezium. It runs on this platform called Kafka Connect, which is this Java thing that I'm going to talk about later, right? But what it does is you set up a logical replication slot in your Postgres database, and then you've got this Debezium process which reads the write-ahead log, which is the commit log of your database, right? In a serial, it processes it serially in one Java thread, all the changes, and gets to Kafka. And in that way, you achieve this consistency where you know that if it, because Debezium is checkpointed, right? And it also has at least once delivery and guaranteed ordering, you can ensure that your database matches what's in Kafka. So imagine like this world, maybe most of us probably use, if we're using a relational database, have like a normalized database, right? So in my example here, I've split my user records into 3 tables. There's a user table, there's an accounts table, and a profiles table. Maybe I like store their settings, right? This is kind of common. This is normalization in a database. If you do like change data capture, right, you got to realize that you're kind of leaking the implementation details of your database into your stream. Because now all the downstream stuff is just it gets a user record, a profile record, an account record. It has to know what those are. It kind of has to know what the upstream database looks like, which is not like a full, clean decoupling. And in Rails, we've got these conventions like these polymorphic relationships and single table inheritance. Guess what? Now all your downstream systems need to know what that is, right? Which isn't necessarily ideal. It might be okay, but maybe it could cause problems downstream. So there's another option here if you're doing change data capture, which is a system called a transactional outbox. In this scheme, the outbox is a special table that we set up in our database that basically serves like a little mailbox, right, for things going out. And so in this scheme, we open a transaction, we fill out users' accounts, profiles, and we kind of jam all those records together into one JSON blob and put it in the outbox. And then we use change data capture to read the outbox and put it in Kafka queue. And in that way, we have cleanly separated our database schema from what goes into our Kafka queue. We can make that message look however we want. We can kind of jam things together. We can even do like some selects and build some big object and then publish that as a message. We can even do like parent-child kind of relationships. If you're building like an invoice, right, and it's got a bunch of line items, you've normalized that into multiple database tables, but we can jam that all into one message in the outbox and send it to Kafka. For all you Thai folks in the audience, right, just doing like change data capture on your tables is like everyone having their motor scooter, but it's way more efficient and everyone gets there at the same time if we just put everyone on the same scooter, right? Another option is, right, this gets really complicated and we're way outside the realm of sort of normal Rails. You can do sort of an event sourcing pattern, which is log first development, where instead of writing to a database, your app, right, writes directly to Kafka, and then you have a consumer downstream that puts it into a database. This kind of blows apart the whole sort of standard, MVC kind of Ruby on Rails thing. I really hope the future of application development is someone makes a framework that makes this easy, because you need all these kind of complicated things like WebSockets to send reports. It gets all asynchronous, and so don't use this for your startup, right? But if you really want like a really high performance, very highly scalable distributed system, log first development really changes things. This is a version of CQRS, right? Command query responsibility separation, where you're really separating the write operations from the read operations. So as far as this producing is concerned, right, you must choose, but choose wisely. You can do synchronous, asynchronous, change data capture, outbox. Consistent streams require consistent producers. All right, so let's talk about a little bit about consuming messages from Kafka, because that's there's some gotchas in there too, right? Here, item potency is key, because the flip side of at least once delivery is that sometimes you can get duplicate messages. So in this world, like imagine you've got a user record. We insert we've got like a create, right, an insert, and then we update it, and then update it and delete it. You might get that delete message twice, right? You can either have at least once delivery with duplicates, or not duplicates, but not at least once delivery. You can't have both, right? And so the trade-off that Kafka makes is sometimes you get dupes. So your logic, if it, for instance, gets 2 delete records in a row, has to not error. You need some kind of check to make sure, like, is this thing already deleted right before you delete it? Or are you going to have problems? There's also this technology called the dead letter queue, which is like, if your consumer picks up this message, but this one is unprocessable, put it in this dead letter queue, but continue on. But honestly, I don't recommend it for most use cases. Usually when people come to me and say, hey, Brad, I want to use the dead letter queue. If you get a message like maybe it's malformed, or maybe our business logic has an error, errors out, because you break the ordering guarantee. If you have insert, update, 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 right? If that middle update gets put in the dead letter queue, maybe you reprocess it later and you rewrite new data with old data, right? Not good. Here's a few use cases, all right? That's Jake Krebs. He invented Kafka. I just want to run through like a few common patterns and scenarios and ways we use this at Procore, right? One is this like multicast idea. This is great for like I said before, we have a separate search platform, separate like machine learning platforms, right? Because Kafka supports multicast, multiple consumers, it's wonderful, this kind of stuff. We write one message to Kafka, we can have an email service, pick that up and send out an email, right? How you make that idempotent, just a little tricky, but we're sure it gets to all these places. Heterogeneous data stores, right? This is when you're using separate databases for separate purposes. Like I said, Elasticsearch for search, Snowflake for reporting. Snowflake's awesome, by the way. It's expensive, but if you want a good reporting database. Great stuff. I do want to mention like this. There's this Java thing called Kafka Connect, which sucks because it's in Java, but it does give you a lot of these like connectors for free. So if you need like to put stuff in Elasticsearch or put stuff in Postgres or put it in an S3 bucket, it's got all that stuff pre-built. You just have to run Java. It's a pain. But it does help you. Java, God, why? That's the sad thing about this. When you get outside of like the web realm and data stuff, you run into this. It's kind of unavoidable. Data lake, right? So here's an interesting one. A data lake, for those of you who don't know this concept, is just like a dumping ground for all your data, right? We use AWS S3 for this, right? And so what we do by default is our streaming platform, we have it automatically configured. When someone makes a new Kafka topic, we automatically create this sink that stores it all in S3. So for that, all of our Kafka topics have permanent backup all the time in S3. And the dream, we haven't done this yet, is to be able to replay it. So if we could get that stuff out of S3 and back into Kafka, like go back 2 years, load it out of S3, back into Kafka, and replay the stream. We don't have that yet, but that's the dream. Materialized views, here's an interesting one, right? If you're using like some kind of NoSQL database, like a Dynamo or like a MongoDB, right? And you have like, here's the list view in a table, here's the item view in the table, here's an aggregate where I like, group by and have like monthly view counts or something like that. You can have separate consumers in Kafka, each to populate these separate database tables. It's a good way to do materialized views and with different databases if you want. Region-to-region replication, this is a big one for us because, like I mentioned, Procore runs in Europe. Procore runs, well, soon it will, North America, right, and other places. So you can use Kafka to replicate things by having a consumer out of in one region, consume out of another region. There are a few different patterns. Another option is to use this thing called Mirror Maker, which will actually replicate Kafka topics across regions, and in that way you can make a sort of a global messaging system. I'm going to skip that and that. One thing that I will mention, right, is just if you go about doing this, consider doing like sort of a messaging standard, which just means like in your organization, pick a set of like required headers, right? For ours, we have the origin zone. There's always a timestamp. There's always a request ID. There's always a user ID. This just helps you make a coherent messaging system. If you've got a set of standards, right? So all these different teams, and enforce that in your tools, right? Make user libraries for whatever, Ruby and for TypeScript that kind of automatically populate these headers, have something in there that separates like production data from test data, things like that. And you have a choice of serialization options. JSON is the easiest because it's schemaless, but if you really want to be sort of diligent in your messaging system, you can define all the types ahead of time and serialize them, like we use protobuf. And then you can do really neat things like if a message arrives at a database and it's got a new column, you can like automatically add the new column, right? And do automatic migrations downstream and cool things like that. It gets complicated. It may not be worth the squeeze, but it is an option. So streaming gives us a globally distributed, eventually consistent, near real-time way to send messages between services and across zones in a way that's fast, reliable, with strong guarantees that it is correct. I recommend it for any of your non-trivial use cases for your enterprise software, for those of you with multiple teams, with complicated applications, right? I really think it's the way to go. I was going to get into Flink. I don't think I have time. I think I'm out of time. But I just want to point out this article. This is sort of the original. I'll post the slides, right, on Twitter. It's not X, it's Twitter. I'll post this article. This is sort of the canonical article by Jay Krebs about log-driven development that's really wonderful. I'm Brad Urani. Feel free to reach out to me. Thank you very much.